Imagine standing on a planet where the sky is deep blue, almost beautiful, almost familiar, like a distant reflection of Earth. For a moment, it might feel calm, even peaceful, like a place you could breathe, like a place you could survive. But then the wind begins to rise, not gently, not gradually, but violently, like the entire atmosphere is tearing itself apart. And suddenly, the rain starts. Not water, not ice, but microscopic shards of glass, blasting sideways at speeds faster than sound, slicing through anything in their path. This is not a nightmare. This is not science fiction. This is a real planet, and its name is HD 189733b. Located about 64 light-years away from Earth, HD 189733b is one of the most studied exoplanets in modern astronomy. At first glance, it doesn't seem unusual. It's a gas giant, similar in size to Jupiter, orbiting a star not too different from our own Sun. But the similarities end there. This planet exists in conditions so extreme that they challenge everything we think we understand about weather, matter, and survival itself. HD 189733b is classified as a hot Jupiter, a type of gas giant that orbits extremely close to its host star. While Jupiter takes about 12 Earth years to complete a single orbit around the Sun, this planet completes its orbit in just over 2 Earth days. That means it is incredibly close to its star, so close that it is constantly bombarded with intense radiation and heat. The result is an environment where temperatures can exceed 1,000 degrees Celsius, hot enough to melt metals and vaporize solid materials. Now think about something simple, something ordinary. Sand. On Earth, sand is harmless. You can hold it in your hand, walk on it, build with it. But sand is made primarily of silicon dioxide, the same material used to make glass. And under extreme heat, something interesting happens. Sand doesn't just get hot, it vaporizes. It turns into gas. On HD 189733b, the temperatures are so extreme that silicate materials in the atmosphere exist not as solid grains, but as vapor. The air itself is filled with particles that can condense into tiny fragments of glass. These particles are constantly forming, breaking apart, and reforming in a chaotic atmospheric system driven by unimaginable heat. But heat alone doesn't make this planet terrifying. The real danger comes from its winds. The winds on HD 189733b are among the fastest ever recorded on any planet. They can reach speeds of up to 7,000 kilometers per hour. That is more than 5 times the speed of sound. For comparison, the fastest winds on Earth, found in the most powerful hurricanes, rarely exceed a few hundred kilometers per hour. What exists on this planet is not weather as we understand it. It is something far more violent, far more destructive. These extreme winds are caused by the massive temperature difference between the day side and the night side of the planet. Because the planet is tidally locked, one side always faces the star, absorbing constant heat, while the other side remains in relative darkness. This creates a continuous flow of energy, driving winds across the planet at unimaginable speeds as heat tries to redistribute itself. Now combine these winds with an atmosphere filled with vaporized glass. As temperatures fluctuate and silicate vapor cools, it condenses into tiny fragments of glass. On Earth, rain falls downward because of gravity, but on HD 189733b, the winds are so powerful that they push these particles sideways. Instead of falling gently from the sky, the glass is blasted horizontally, traveling at supersonic speeds. This is what scientists refer to as glass rain. But the term rain doesn't fully capture what is happening. This is not a gentle shower. It It is more like a continuous planet-wide sandblasting process. Billions of microscopic glass particles moving at extreme velocities, capable of eroding, cutting, and destroying anything in their path. For a human were somehow able to stand on this planet, survival would be impossible. The temperature alone would be enough to cause instant fatal damage. But even before heat became the primary concern, the glass rain would tear through skin, eyes, and tissue almost instantly. There would be no time to react, no time to understand what was happening. The environment is simply too extreme. What makes this even more fascinating is that scientists didn't discover this by direct observation in the traditional sense. No spacecraft has landed on HD 189733b, no probe has entered its atmosphere. Instead, everything we know comes from analyzing light. Using advanced telescopes, scientists observe how light from the host star passes through the planet's atmosphere. This technique, known as spectroscopy, allows researchers to identify the chemical composition of distant worlds. By breaking light into its component wavelengths, they can detect the presence of specific elements and compounds. In the case of HD 189733b, the data revealed the presence of silicate particles in the atmosphere. Combined with temperature models and atmospheric simulations, scientists concluded that these particles could condense into glass under certain conditions. The extreme wind speeds provided the final piece of the puzzle, explaining how this glass could move sideways at such incredible velocities. Another intriguing aspect of this planet is its color. HD 189733b appears as a deep, vivid blue when observed through telescopes. At first glance, this might suggest something familiar, something similar to Earth's oceans or sky. But this appearance is deceptive. On Earth, the blue color comes from the scattering of sunlight by molecules in the atmosphere and reflection from oceans. On HD 189733b, the blue color is caused by light scattering off the silicate particles in the atmosphere. In other words, the same glass particles responsible for the deadly rain are also responsible for the planet's beautiful appearance. This creates a powerful contrast. A planet that looks calm and inviting, in reality, is one of the most hostile environments ever discovered. And this leads to a deeper realization. The universe doesn't operate based on human expectations. What looks familiar may not be safe. What appears beautiful may be incredibly dangerous. Our instincts, shaped by life on Earth, are not reliable guides when it comes to understanding other worlds. HD 189733b is just one example of this broader truth. There are exoplanets where it rains molten iron instead of water. There are worlds with surfaces covered entirely in lava oceans. There are planets with atmospheres so dense that light struggles to pass through them. Each discovery expands our understanding, but also reminds us how limited our perspective is. Studying extreme planets like HD 189733b is not just about curiosity, it has real scientific value. By observing how matter behaves under extreme temperatures and pressures, scientists can refine models of atmospheric physics, chemical reactions, and planetary formation. These insights can then be applied to other systems, including our own. It also forces us to rethink what we consider normal. On Earth, rain is a gentle, familiar process. It nourishes life, shapes landscapes, and supports ecosystems. But on another planet, the same basic concept, particles condensing and falling through an atmosphere, can become something entirely different, something deadly. This highlights an important idea. The laws of physics are universal, but their outcomes can vary dramatically depending on conditions. Temperature, pressure, composition, and energy all interact in complex ways, creating environments that can seem almost impossible from our perspective. And yet, they exist. HD 189733b is not an exception. It is part of a vast and diverse universe filled with worlds we are only beginning to understand. As technology advances, we will discover more planets like this. Some may be even more extreme. Some may challenge our understanding in entirely new ways. And among them, there may also be planets that are more similar to Earth, places where conditions allow for liquid water, stable atmospheres, and perhaps even life. But the existence of planets like HD 189733b serves as a reminder that habitability is rare and that the universe is not designed with human life in mind. It is vast, complex, and often hostile. And yet, it is also incredibly fascinating, because every new discovery pushes the boundaries of what we know. Every new planet adds another piece to the puzzle, and sometimes those pieces reveal something unexpected, like a world where it rains glass, sideways, at supersonic speeds,